Hello everyone, welcome back to your favorite and India's most affordable learning platform, Physics Wallah. So in the last session of rotational motion, we discussed about the conservation of angular momentum, right? So we have solved the questions related to the conservation of angular momentum, right? So today we are going to deal with the lecture number 9 of the rotational motion. So I'll take one more session. So total 10 lectures I'm going to take for the rotational motion chapter. Okay, clear? Chalo. So today our topics will be first, so rolling, then what is pure rolling, and questions on kinetic energy in rolling, and then the angular momentum in the rolling concept. So before that I gave some homework questions, right, in the previous session. So I'll solve them first, so then I'll go for the today's topic. Okay, so as usual I just need your attention for the next 1 hour, guys. So just be with me, avoid all the disturbances around you. So and at the end of the lecture it's very important to prepare your own short notes. So with very high positive energy, let's begin the today's session. So what are our topics? First one, so this question I gave it as a homework for you in the last session. So a small mass m attached to a string rotates on a frictionless tabletop as shown. If the tension on the string is increased by pulling the string, causing the radius of the circular motion to decrease by a factor 2, so the kinetic energy of the mass will be. See here. So first try to understand the given question. So what they are saying? This one, right? So let me take the new slide here. So first, initially there is a string. A small mass attached to a string rotates in a frictionless table as shown. So this is of radius r. So this is the string and here the mass m is attached. So now it is rotating on a table, so on a frictionless table. Now, so if the tension in the string is increased in pulling the string, causes the radius of the circular motion to decrease by factor 2. So that means we pulled this string, we applied the force and we pulled this string. So then what happens? So this is the center. So now the mass has come here. So the radius has decreased by r by 2. So the radius has decreased by r by 2 from here to here. So now what is the kinetic energy in this case they are asking? So what is the kinetic energy of the mass will, what happens? Increases or decreases or remains constant? So we have to discuss. See, first thing is, so if you are increasing the tension is nothing but force, right? So you are increasing the tension towards the center. So if you increase the tension, shall I say there won't be any torque? Why? Because that force is acting along the axis. About this point you are finding the momentum, right? Angular momentum. So here simply we can say that there is no torque, external torque. So force is there, but the torque due to that force will be 0 because that force is passing through the axis. Wherever you are finding the torque, so the force is passing through that axis, right? So that's why the net torque, the external torque is equals to 0. So I can apply the conservation of angular momentum here. So we can apply, so the conservation of angular momentum. Alright. So see here. So what's let's say L initial is equals to L final. So it's moment of inertia I omega 1. Let's write. So I, so same mass. So I, so let's say it's omega 2. Yes or no? So shall I write here? So I is what? This is a ring, right? So a mass of a string attached to it will be like a ring. So that's why it's going to be mr square into omega 1 is equals to I, here moment of inertia, here I1, let's write I2. So which is nothing but m, the radius has become half. So m r square by 4, so into omega 2. So right, so from here, so I can write m r square omega 1 is equals to, so m r square by 4 omega 2. So from here mr square cancel. So the omega 2 will be equals to 4 omega. Omega 2 will be equals to 4 omega, right? Chalo. So the new angular velocity of this will be, so this is a new angular velocity omega 2 which is 4 times omega. So here it is rotating with the angular velocity of omega. So now we need actually what happens to the kinetic energy. So let's write what is the initial kinetic energy for the rotating body. The kinetic energy will be half I omega square, right? So half I is nothing but m, so its radius is r, so r square omega square, right? So now let's find what is the final kinetic energy here. So the final kinetic energy is half I. So here the, let's say this is I2, so then the moment of the angular velocity omega 2 square. So from here I is a half into I2. What is I2? So m r by 2 whole square, right? mr square means m r by 2 whole square into, so what is omega 2? Omega 2 is 4 omega whole square. So from here I can write half mr square by 4 into 16 omega square into 16 omega square. So now let's do one thing. Half mr square omega square, let's write here half mr square omega square, and then write 16 by 4 here. 16 by 4 is 4 times half mr square omega square. So this is nothing but 4 times initial kinetic energy. So half mr square omega square is initial kinetic energy. So that means, so when you decrease its radius by a factor of 2, so r by 2, r by 2, so then its kinetic energy increases by 4 times. Clear? So it increases by a factor 4 times. So I can say the kinetic energy increases by a factor of 4. Simple question. Done? Clear? Chalo. So let's take one more question, guys. So this question also I gave it as a homework in the last session. So what's the question says here? A mass m moves in a circle on a smooth horizontal plane with velocity v0, so at a radius r0. Okay, so the mass is attached to the string which passes through the smooth hole in the plane as shown in the figure. Fine. So the tension in the string increased gradually and finally moves in a circle of radius r by 2. Same question. So they increased the tension, that means they pulled, so the radius has become r0 by 2. So the final value of the kinetic energy is, so the final value of the kinetic energy. So how do we find that? Simply, shall I say that so the angular momentum is conserved first. The angular momentum conserved, because so if you cause the tension, so the tension is along the on the axis of the center, right? So that's why the torque due to the tension will be 0. So as the external torque is 0, we can say that the angular momentum is conserved. The angular momentum conserved. So that means initial angular momentum is equals to, so the final angular momentum. The initial angular momentum is equals to the final angular momentum. So from here, so initially let's suppose it has I1 omega 1 is equals to I2 omega 2, let's say. So what is I1? So it is moving in a circular path of radius r0. So m r0 square into, so omega 1, let it be omega 1 itself. So its radius decreased to r0 by 2. So m here r0 by 2 whole square into omega 2, right? So from here I can write m r0 square into omega 1 is equals to m r0 square by 4 into omega 2. Same concept previous one. m r0 square cancel. So the omega 2 will be equals to 4 times omega 1. 4 times omega 1. So but what we need the final kinetic energy. So initially when it is revolving in a circle of radius r0 with a velocity v0, so its kinetic energy, so the kinetic energy Ke is equals to half I omega square, half I omega square, right? So from here, so we can write half I. What is the moment of inertia initially? M r0 square, m r0 square, yes sir, sorry, m r0 square into omega square, right? So this is the initial kinetic energy. So or else you can write, they gave the linear velocity v0. See here. So with a velocity v0 they gave, so we can take this omega also. So what we can write in place of this omega, We know that V naught is equals to R omega. Yes or no? R omega. Can we write this? V naught, V is equals to R omega, right? So the same thing I'm writing. So half M R naught square into, in place of omega, we can write V naught by R. So here V naught square by R naught square. So R naught square cancel. So this will become half M V naught square. Or else you can directly consider it as direct kinetic energy. So now here its radius decreased to R naught by 2 upon applying the tension, increasing the tension. So now what will be its final kinetic energy? So the final kinetic energy is half into, so its moment of inertia is M R naught by 2 whole square into, M R naught by 2 whole square into, just a minute guys, I'll just keep my phone silent, very sorry. So M R naught by 2 whole square into, what is this omega? So what's the omega for the previous one? 4 omega 1, 4 omega 1, 4 times the omega 1. So I can write half M R naught square by 4 into 4 omega 1 square. So which is nothing but 16 times. So in place of omega 1, so we can write V naught by R whole square, V naught by R naught whole square. So which is nothing but half into M R naught square by 4 into, so this is going to be 16 into V naught square by R naught square. So R naught square gets cancelled. So 4 ones are 4, 4s are. So which is nothing but 2 ones are 2, 2s are. So here it becomes 2 times M V naught square. So the final kinetic energy will be 2 times M V naught square. Option 3 is the correct one. Clear? Understood everyone? They are asking what is the final kinetic energy, the value of the final kinetic energy. So in the previous question, so how much kinetic energy has increased? So that's what they are asking. See, actually this kind of questions you can directly do. Initial kinetic energy you already know. So how much? Half mv naught square. So it increases by a factor of 4, right? From here to here. When the radius decreases to half, so its kinetic energy increases by a factor of 4. So half mv naught square into 4 if you do, so you'll get 2 mv naught square. So directly also you can do. Done? Clear? Chalo. So let's go for the next question guys. So the question number 3. So what's the question says here? A force F which is vector is given is acting at a point, some position vector is given, the value of alpha for which the angular momentum about the origin is conserved. So that means L is conserved. So if L is conserved means, so shall I say the torque external is 0? The torque external is 0. What does it mean by torque 0? So torque is nothing but torque 0 which is R cross F0. Here we have got what is R vector and what is F vector. So simply make their cross product equals to 0. So what is R vector? So the R vector is 2 I cap minus 6 j cap minus 12 k cap, right? And then so F it is alpha I cap plus 3 j cap plus 6 k cap, right? So now do the R cross F. So this is I cap, so minus j cap and then k cap. So what is R? 2 minus 6 and then minus 12. 2 minus 6 and minus 12. So and then F, what is F? So alpha 3 and then 6. Alpha 3 and 6, right? So then so the torque is equals to R cross F. So how do you do the R cross F here? So I into, so minus 36 and this minus 36. So minus of minus 36 plus 30, sorry. R cross F. So first I wrote R only, right? R components 2 minus 6 minus 12. 2 minus 6 minus 12 and then alpha 3 6, fine. So R cross F. So what we do R cross F here? So the torque is equals to 0 and then I am writing here I cap into, so AD minus BC. So what is AD minus BC? Minus 36 minus, so row, close this column, close this row, close this column. So minus 36 minus of minus 36 which is plus 36. So this will become 0 and minus j cap close this column and close this row. So 12 6 are 2 6 are 12 minus half minus plus, so this will be 12 alpha, fine. So and then so plus k cap, so which is, so close that column and close that row, minus 6 alpha and then minus 6 alpha and then minus 6 is equals to 0. Yes, this whole thing should be equals to 0. So what we got here, so the overall this equals to, what is this one, 12 plus 12 alpha. So the cross product, did I do any mistake? Cross product, I minus j k, so 2, so close this column, minus 36 plus 36 cancel, so and j cap, so close this column, close this row, so then 2 into 6 12 minus half minus plus 12 alpha and then k cap, so which is 6, 2 into 3 6 minus half minus plus 6 alpha, sorry, so plus k cap into, so what we can write here, this part, so 2 into 3 6 minus of minus 6 alpha is plus 6 alpha, right. So then we can write it like, so this whole thing is 0, however this is 0, so 0 into something 0, so if you send it to this side, so 12 plus 12 alpha into j cap is equals to 6 plus 6 alpha into k cap. Yes, so then, so we need just the magnitude, right? Better, so let's go for this procedure. 12 plus 12 alpha is equals to 0, so 12 is equals to 12 alpha, alpha is, so we can go for this, so 12 plus 12 alpha is equals to 0, so from here 12 is equals to minus 12 alpha, from here alpha is equals to minus 1, or else you can make this equals to 0, so which one, this part, so 6 plus 6 alpha is equals to 0 and 6 is equals to minus 6 alpha and alpha is equals to minus 1, this is the simplest one, or else you can follow the another method, so whenever r cross f is 0, method 2, so this is the easiest method, so what is that, so the two vectors are there, r vector is given, so what is that, 2 I cap minus 6 j cap minus 12 k cap, and then f vector is given, so what is that, alpha I cap plus 3 j cap plus 6 k cap. So then we can write like, so 2 by alpha is equals to minus 6 by 3 is equals to minus 12 by 6. So you can equate any 2 here. So here 2 into 3 6 is equals to minus 6 alpha. So from here alpha is equals to minus 1, or else you can equate these two also, sorry, these two also, your wish. Minus 12 alpha is equals to 12. So from there alpha is equals to minus 1. So this will be the easiest one. You can just compare the, like you can just take the ratio of their components if they are parallel, right? R cross f will be 0 means, simple thing, right? R cross f is equal 0 means R is parallel to f, right? So then only the cross product will become 0. So if they are parallel, so we can use this 10th class level math, right? Clear? Shall. So let's go further. So let's go for the next question, guys. So what's the question says here? If the radius of the earth contracts to half of its present value, so without change in its mass, so what will be the new duration of the day? See here, so this is a earth. So the radius of the earth contracts to half of its value. Let's suppose initially it is r. Now here its radius contracted to r by 2. So then what happens here? So without changing its mass, so its mass remains same, right? So then obviously if its mass remains same, its moment of inertia will be the angular momentum will be conserved in this case. So the angular momentum I1 omega 1 is equals to I2 omega 2, shall we write in this case? So here the earth is nothing but which we consider it as a solid sphere, right? Earth is a solid sphere. Solid sphere. So now I can write, so the moment of inertia initially it is 2 by 5. So mass m into radius r square, right? So what is omega 1? So let's suppose it is moving with angular velocity omega 1. So initially, so and then I2, so its moment of inertia now, so same sphere half into its mass is same, but radius has become r by 2. So r by 2 whole square, right, into omega 2, right? So from here, so here I can write mass gets cancelled. So 2 by 5 gets cancelled. So we can write, so r square, here r square also we can cancel. Omega 1 r square is equals to r square by 4 into omega 2, right? So which is nothing but r square also gets cancelled. Yes, so from here we can write, so the omega 1 is equals to, or omega 2 is equals to 4 omega 1. Omega 2 is equals to 4 omega 1. So that means, so now the earth rotates with a angular velocity of 4 times of the previous one. So now what will be the time period we can find? How do you find the time period? So initially, so the omega is when it rotates in a radius of r, so the time period should be 24 hours, right? Initial time period. So that means when the angular velocity is omega 1, its time period should be 2 pi by t1. Its time period should be 2 pi by t1. Now, so what will be the time omega 2 when its angular velocity is omega 2? So then I can write, so 2 pi by time period t by 2. So time period t by t2. Yes or no? So let the new time period be t2. So now see here. So we know this one, omega 1 is equals to 2 pi by, this is 24, right? So now in place of omega 2, shall I write 4 omega 1, which is equals to 2 pi by new time period t2. So from here 4 into, so what is omega 1? Omega 1 is this thing. So 2 pi by 24 is equals to 2 pi by t2. 2 pi by t2. So here 2 pi gets cancelled. 4 ones are 4 6 are. So t2 is equals to 6 hours. So that means new time period will be 6 hours. So why? Because its angular speed increased by 4 times. Yes or no? Its angular speed increased by 4 times. So obviously the time period decreases. The omega and t are inversely proportional, right? Omega and t are inversely proportional. So 2 pi is the constant one, right? So if its angular velocity increases by 4 times, its time period decreases by 4 times. So time period initially it is 24 hours, it decreases by 4 times means 24 by 4, which is 6 hours. Clear guys? Understood? Logical question again. Chalo, so the next one, a solid sphere is rotating freely about its symmetry axis in free space. So the radius of the sphere is increased to keep its mass same. Radius increased to keep its mass same. So which of the following physical quantities would remain constant for the sphere? Obviously, the angular momentum remains constant. We already discussed 2 to 3 questions based on this. Right? Done? So chalo, so next. So now let's come to the next part. So that is the rolling motion. See, the rolling motion is a vast topic. Okay. So very big topic. So but we will study what is important for our competitive examination. So if you want me to take, I can take the very complex question and solve it here. But we don't require it for competitive examination. So we have to stick to our concepts, like stick to our what is required for us to crack JEE or to crack NEET or to crack other competitive examinations, state level competitive examinations. Okay, so in all these examinations, whatever the concepts they are asking the questions based on rolling motion, so those concepts I am going to cover. Okay, so today's lecture and tomorrow's lecture completely will be on rolling motion itself from now. Okay, so in 2 sessions I'll complete the entire rolling motion. So whatever the concepts and standard results I am going to teach, you have to practice those and some questions apart from whatever we are doing in the class. Okay, clear guys? Chal. So first, what is the rolling motion? Rolling motion is a combination of translation motion plus rotation. Rolling motion is a translation motion plus rotational motion. So simply first understand the feeling of rotational motion. So let's suppose a wheel is rotating like this. A wheel is rotating like this. So then its center of mass moves. Let's suppose this is the wheel. So this wheel is rotating. So this wheel is rotating and moving forward. So shall we say its center of mass is making the translation motion. Its center of mass is making the translational motion, right? And every particle of the wheel are making the rotational motion. Every particle of the wheel are making the rotational motion, and its center of mass is moving in a straight direction, right? If the wheel is rotating like this and moving forward, so its center of mass moves in this direction. Its center of mass is moving in this direction, which is nothing but the translation motion. So and then every other particle will make the rotational motion. So that's what I wrote. So like how we splitted the projectile motion into x direction and y direction, in the similar manner in the rolling motion questions we are going to split it into so the translation motion and rotation motion, so then you can solve any question. Okay, so try to understand this part. So we'll take the questions, you will understand better. So the center of mass moves with a velocity v/c/om. This is the velocity of center of mass, and all the other particles will have the angular velocity omega. Clear? Done? So just a minute guys, I'll just decrease the AC. Fine. Now next, so let's take one simple question here. So what's the question says? A disc of radius r is equals to 3 centimeters starts at a time t is equals to 0 moving along the positive x-axis. So moving along the positive x-axis with linear speed v is equals to 2 centimeter per second. So angular speed omega is equals to pi by 6. So find the displacement of the bottommost point at t is equals to 3 seconds. At t is equals to 3 seconds. First, try to understand the question. What they are saying? Initially, the wheel is here. Okay, so it is on the x-axis like this. It is on the x-axis like this. So there is a bottommost point. Let it be point P. Now, after some time, so this point has reached. Let's suppose, as the wheel rotates, what happens? So this point will reach somewhere around here. As the wheel rotates, so this point moves to somewhere this here. So now what is the displacement they are asking? From here to here, what is the displacement that is moved by the particle? So the bottommost particle. Okay, so first what I am doing is, so the body is making translation motion from here to here. The translation motion from here to here. The center of mass initially, this is the velocity of center of mass, and here this is the velocity of center of mass. So now, so linearly it is making some distance from here to here. Yes or no? And then, so and again the wheel rotating part, the P point is coming back. It went till here. This is linear motion, and then from here the point P is here. So you have to subtract this point. So then we get this. So then we know this, and we have to find this displacement. I'll solve so that you will understand better. See here. First consider the rotational motion. First consider the rotational motion of the body. So if you consider the rotational motion, so we know that the body is making, so see here, when it reaches this point, so we know theta is equals to omega into t. Theta is equals to omega into t. Yes or no? How much angular displacement the particle will make. So the theta is equals to what's the omega? It is given in the question. Omega is pi by 6, right? And then, so t is what? So t is in 3 seconds they are asking, right? In 3 seconds. So that means 3 ones are 3 twos are. So which means the particle will make a angular displacement of pi by 2. So which particle we are talking about? So the P particle. So the P particle, while the wheel rotates, it makes an angular displacement of pi by 2. So what does it mean by angular displacement of pi by 2? So the wheel will move here. This will be the pi by 2, right? Initially it is here. So now it moved to a point here. So that means the P point has moved to this point. The P point, which is from here, it is moved to here. So now the center of mass is making the linear motion. Yes or no? So if you consider the linear motion, so we know that, so the velocity is equals to displacement by time. from here the displacement is equals to, so v into time. So we need this distance from here to here, how much distance the center of mass has moved in the translation motion. So what's the velocity with which center of mass is moving? Velocity v is given 2 into, so in what time? 3, so which is 6. So this distance is 6 centimeters. Which distance? This total distance is 6 centimeters. This total distance is 6 centimeters, and then so 6 centimeters from here to here. But what we required in the question, what they said, so find the displacement of the bottommost point. Displacement of the bottommost point. Bottommost point has moved from here to here, here to here. So then shall I say that the displacement will be this part? Actually we need this part. So what will be the distance till here? What will be the distance till here? Tell me. What will be this total distance is 6. So now can we subtract the radius from here? Can we subtract the radius from here? What is the radius of this one? What's the radius is 3 centimeters they said. So if this is 3 centimeters, so from 6 if you subtract 3, so this whole thing will be again 3 centimeters. Yes or no? And then this is 3 means this is all it is also radius, right? The displacement means this point we required, this distance from here to here. Understanding? So we first calculated how much distance the center of mass has moved. That's a linear motion. And how much distance this particle has made rotationally. That's the angular displacement. So this point has moved from here to here. The total displacement will be from initial to final. Initial to final. We know this total distance, which is 6. From here we are subtracting this radius, so that from here to here it is 3, and then this is also the radius, so which is 3. Now I need, this is 3, this will be 3 root 2 obviously. So that distance will be 3 root 2 centimeters. That's it. Okay now, understood guys? Simple question. So let's go further. So same question. So let me derive the general formula for that. So a disk of radius r starts at time t is equals to 0, moving along the positive x-axis with the linear speed v and angular speed omega. So find x and y coordinates of the bottommost point at any time t. Previous one we calculated with some values. So this question I am going to do it with the variables. So what's the question says? Same question. At time t is equals 0. So this is a wheel. So this is a bottommost point. This is a bottommost point. Let's consider this one. Okay. So from here the wheel has moved to this place. So here is the bottommost point P. So now after some rotation, after some time, so the P point has moved to some other P dash. So this is a P. So it has moved to some other point. So further to move from here to here, it's making some angular displacement theta. It's making some angular displacement theta. Same procedure you can follow here. So how much angular displacement, and its center of mass is moving from here to here. So this is a total distance from here to here. So first rotational motion. Consider the rotational motion of the P particle. So the rotational motion if you consider, so we can take this as, so this P particle is rotating and moving here. So we can say that the theta is equals to omega into t. The theta is equals to omega into t. So let's consider now the linear motion. Let's consider the linear motion of the particle. So which is nothing but, so v is equals to the displacement into time. Sorry. Linear motion. So the displacement is equals to v into t. So how much, with what velocity? This is moving with a velocity v, right? So this center of mass is moving with a velocity v, and in time t it reaches this point with a velocity v, right? So then that s is equals to v into t. So what we required, actually we required, so the s x and y coordinates. So when this particle moves here, so we actually need this distance from here to here distance we required, and then this whole thing we required. So now how do you subtract this part? See here. So from total Vt, you have to subtract this point. This total distance is Vt, right? This total distance is from here to here in the linear motion, it is Vt. So now from this Vt, you have to subtract this point. So what is this one? So we can write this as, so this is the radius. So we can take this as two components here. What are the two components we can take? So one will be this component. So let's write this way. This is fine, but let me write here like this. So with the center, this is the center I am considering. So this is the one. Okay, fine. So now see here, we actually need this height and we actually need this distance. So then we can subtract it. So here, if this is angle theta, so this component will be r sin theta, and this component will be r cos theta, r sin theta, r cos theta, right? So from here, so what will be this distance? The total should be r. This will be r minus r cos theta. This will be r minus r cos theta. So now we have got everything. So what will be this distance? Tell me. From here to here, total Vt minus, you subtract r sin theta. This will be Vt minus r sin theta. Yes, this is a x. And what will be the y? What is this total distance? So the total is r minus, this is r cos theta. So the x component is Vt minus r sin theta. Yes or no? So this whole thing will be Vt. From here we are subtracting this part. What is this part? R sin theta. So Vt minus r sin theta. And then what is this thing? So whole this radius is r minus. So the r cos theta component we are subtracting. So r minus r cos theta. So in place of theta you can substitute the omega t. So if you need Vt minus r sin omega t, you can write here also r minus r cos omega t. So if you want, you can take r common. So if you take r common here, so 1 minus cos omega t. 1 minus cos omega t. Vt minus r sin omega t and r into 1 minus cos omega t. Option 2 is the correct one. So this is the general formula you can use in the previous question also. Done na? Understood everyone? Chalo. So let's solve the next question. So what's the question says here? A disc of radius 1 centimeter is rolling with a linear speed v is equals to 4 centimeter per second and angular speed 3 radian per second. Find the velocity of points A, B, C, D. See here. So if the v is equals to, if the center of mass is moving with a speed of 4 centimeter per second means, so every other particle also will move with the 4 centimeter per second. This will move with the 4 centimeter per second, and then this will move with the 4 centimeter per second. This also move with the 4 centimeter per second. This B point also will move with the 4 centimeter per second. So that's fine. But along with 4, so is there any other velocity that is adding up? Because the body is rotating also, right? So its center of mass is moving and the wheel is rotating also. The disc is rotating. So if it is rotating, shall I say that here the angular velocity v is equals to r omega will act this side? Yes or no? And then here also the v is equals to r omega will act this side. And then this side also v is equals to r omega will act. Yes. So here also one more velocity v is equals to r omega will act. So what is that? V is equals to r omega we have got. So r is, what is r radius? 1 centimeter into omega is 3. So which is nothing but 3. So that means here 3 will be in this direction. So here 3 will be in this direction, and here 3 in this direction, and here 3 in this direction. So now if you observe at point A, you can see that 4 is a velocity which is due to the center of mass moving. So 4 right side, and then 3 is due to the rotational motion. Total 7 centimeter per second. At A the velocity is 7 centimeter per second. So now at B, if you observe, so 4 centimeter per second due to the center of mass, translation motion, and 3 centimeter per second due to the rotational motion. So the resultant will be 5 centimeter per second. So the total final answer is 5 centimeter per second for the point B. So now for the point C, you can observe. So this side 4 centimeter per second due to translation motion, and this side 3 centimeter per second due to rotational motion. So overall it will be 1 centimeter per second for the point C. And for the point D, you can see that 4 centimeter per second, so due to translation motion, and 3 centimeter per second due to rotational motion. So overall this will be 5 centimeter per second. This is 5 centimeter per second. Clear? Understood, guys, everyone? This part. Chalo. So next. So let's go to the pure rolling part. So what is pure rolling? If the point of contact is at rest with respect to the ground. So this is the bottommost point. So this is the point, bottommost point. So which is in contact with the ground. So if it is at rest with respect to the ground. So that means the velocity of point P with respect to ground should be equals to 0. The velocity of point P with respect to ground should be equals to 0. So we can write it as velocity of point P minus velocity of G, velocity Vp minus Vg. So is equals to 0. So you know that velocity of the ground is 0. So the ground is not moving here. So the velocity of the ground, you can take it as 0. So the velocity at point P is equals to 0. So what velocities will be there at this point? So one is the velocity due to the center of mass, that is one velocity. And then, so if it is of radius r, so then one more velocity will be there due to the rotational motion. So this velocity is due to the rotational motion. Try to understand the concept, guys. This velocity is due to the rotational motion. And then this velocity is due to the translational motion. This is due to the translation motion. So from now I can write, so at point P we have two velocities. So these should be equals to 0. So which means the Vc is equals to r omega. I can write Vc is equals to, I can write r omega. That's it. Vc is equals to r omega we can write. Done? Clear? Chal. So this is one definition. Or else you can write one more definition also. So when rolling occurs without slipping, it is called pure rolling. When rolling occurs without slipping. So what does it mean by without slipping? What does it mean by without slipping? So without slipping, there are three cases actually. So the first one here at point P, so there are two velocities. So this is Vc velocity, which is due to the translation motion. And then, so this side r omega will act, so which is due to the rotational motion. Rotational motion. So here slipping, what does it mean by slipping? So if Vc is greater than r omega, if Vc is greater than r omega, so then it is called the forward slipping. Then, so it's called the forward slipping. Or else, so case 2, if I take, if r omega is greater than Vc, if r omega is greater than Vc, so then it's called backward slipping. Backward slipping. Okay. So if Vc is equals to r omega, so the case 3 where Vc is equals to r omega, so this is called no slipping. This is a no slipping condition. So this is a no slipping condition. Vc is equals to r omega. So that means for the pure rolling, you can consider Vc is equals to r omega. Okay. So either you can take it, the point of contact is at rest with respect to the ground, or the rolling without slipping is also called pure rolling. So in the question, if they mention rolling, so consider it as a pure rolling, guys. In the question, if they mention rolling, consider it as a pure rolling. Okay. So we'll solve the question so that you'll understand better. So take this question. Under pure rolling, so find the velocities of A, B, C, D. Under pure rolling, they said. Under pure rolling. So first, each point, if the center of mass is moving with the velocity Vc, A point will move with the Vc velocity, B point will move with the Vc velocity, C point will move with the Vc velocity, and then this point also will move with the Vc velocity. So this also moves with the Vc velocity, right? So under pure rolling, shall I say, under pure rolling, so the Vc will be equals to r omega. So the Vc will be equals to r omega. So that means, shall I write at this point, so there is one more velocity that is acting r omega, at this point, so one more velocity r omega. So here one more velocity, here also r omega, here one more velocity which is r omega, right? So now if you consider the point A, so we can write, so VC is acting right side and r omega is also acting right side. So r omega is nothing but VC in place of in the case of pure rolling, so that the total velocity will be 2VC we can write. So the total velocity is 2VC in A. So now coming to the B case, see here, so VC is acting this side, so r omega means again VC is acting this side, so which means, so VC root 2. So this is in the B case. And in the C case, VC is acting right side and r omega means VC you can write, so VC. So here this is this is D point I am talking about, D point. So here it is VC root 2 again. But coming to the point C, see here, VC this side and r omega is equals to VC, right? So at C it is 0 because the point of contact with the ground should be at rest. With respect to the ground, it should be at rest. So that's why then only it's said to be pure rolling, right? Here the velocity will become 0. Done? Clear everyone? Chalo. So the next question, what's the question says? So a wheel of bicycle is rolling without slipping, on a level road. So that means pure rolling. The velocity of the center of mass is VCM. Okay. So then the true statement is the velocity of point A is 2 VCM. So just now we have seen this point will have obviously 2 VCM. So that's correct. And velocity of the point B is 0. Yes, this point is 0. So this statement is correct. And then velocity of A is 0. No. So the velocity of A is 2 VCM, B is minus VCM, B is 0. So then only it is said to be pure rolling. So both are VCM. So no. So this is 0, this is 2 VCM. Just now we discussed, right? Clear? Chalo. So let's go for the next question. So what's the question says here? Point P is a point of contact of a wheel and the ground. So the wheel rolls on a ground without slipping, and then the displacement of the point P on the wheel completes half rotation is, see here. So this is a wheel. So here is a point P, so which is on the ground. So then when wheel rotates half rotation, so then this point P moves to this point here. So how much is the angular displacement? So from here to here, half rotation means pi radians. Yes or no? So then shall I write, let me consider first rotational motion. So in the case of rotational motion, we can simply take, so the theta is equals to omega t, right? So what is theta? So theta is nothing but angular displacement pi, which is equals to omega t. Let it be. Now consider the linear motion, same procedure. Consider the linear motion. So we actually need the displacement of the point P. So that means from here to here the displacement we required. So from here to here we need, and this one we need. So this we already know, if it is the radius r, so the y component, this is a distance y, right? So let this be the distance x. So y we already know, which is 2r. Y we already know because this is the radius r. After half rotation, this total displacement will be 2r. Y component will become 2r. So we need this x. For that, I am considering the linear motion. So here the displacement in the x direction is equals to v into t s. So from here, s is equals to, in place of v, I am writing r omega. In place of v, I am writing r omega into t. So s is equals to r into, so in place of omega t, let's write theta. So from here, so s is nothing but the x, the linear displacement from here to here. So x is equals to r, the theta is nothing but pi. So therefore we have got x coordinate also. What is that? R pi. So what we need actually? So we need this one. So this whole thing will be x square plus y square, the displacement. So from here, the displacement is equals to, so square root of x square plus y square. So which is nothing but r pi whole square plus 2r whole square, right? So r square you can take out, so which is pi square plus 4. So this is the correct option. So in the question they said radius of the wheel is 1 meter, so you can substitute 1 here, 1 into square root of pi square plus 4, so which is nothing but square root of pi square plus 4, or 4 plus pi square, okay, meters. So this is the option 2 is the correct one. Clear? Understood guys, everyone? Chalo. So next. So now what's the kinetic energy in the case of rolling motion? So rolling motion is nothing but the kinetic energy in the case of translation motion plus kinetic energy in the case of rotational motion. So the kinetic energy of the rolling motion will be equals to, so the kinetic energy of the translation motion plus, so the kinetic energy of the rotational motion. Yes. So what is the kinetic energy of the translation motion? So half m into, so the center of mass is moving with the velocity vc, so half m vc square, right? So plus, so half I omega square, half I omega square we can write here. Yes or no? So in place of omega, so you can also write vc by r, half m vc square plus half into I into, so in place of omega you can write vc by r, because v is equals to r omega, from there omega is equals to v by r. Can we use this? So here I am using that one, so we can write it as half m vc square, so plus half I, so this is vc square by r also you can write, vc square by r also you can write. Clear are this part, everyone? Understood this part? Done? Chalo. Next, let's move further. Let's take one question. So a disc of radius 2 meters and disc, they said, so the disc of radius 2 meters and mass 100 kg rolls on a horizontal floor. So its center of mass has speed 20 centimeter per second. How much work is needed to stop it? So how much work is needed to stop it? So it is rolling, it rolls on a horizontal floor. So the first thing is you have to apply the work energy theorem. So the work done will be equals to, so the change in kinetic energy, the work done will be equals to change in kinetic energy. So final kinetic energy is 0 because it has to stop. So then the work done is equals to, so the initial kinetic energy as it rolls I can write like, so the kinetic energy of translation motion, because it is rolling, right? Translation motion plus, so the kinetic energy of the rotational motion, simple. So now you can substitute the values. So what, how can we substitute here? Negative of, so half m vc square, right, plus half I omega square. So here in the question they did not mention it is a pure rolling or not. So if it is rolling, they did not mention it in the question, you can consider it as a pure rolling guys. So consider the condition of pure rolling. So in the case of pure rolling, you can say that vc is equals to r omega. From there omega is equals to vc by r. Okay, so then I can substitute it here, negative of half m vc square plus half I into, so omega square, what is omega? Omega is nothing but vc square by r square, right? So let's do the simple calculations. So if you want, you can keep this negative sign or you can take it out, take it off. Why? Because so the work will be, however, it's going to be negative because you are stopping, right? So here half m vc square, I'll keep the negative sign at the end. So plus half, so what is the moment of inertia? So for the disc, so disc is nothing but mr square by 2, right? So into vc square by r square. So from here we get half m vc square plus, so this whole thing is m r square vc square by here r square cancel, you can cancel it out, so that we can write with m vc square by 4. So the 4 is the LCM, it goes to 2 plus 3 mvc square. So now substitute the values, 3 by 4 into what is the mass? 100 kg. And what is vc square? So velocity is 20 centimeters. So I'm writing 20 by 100 whole square. Centimeter per second to meter per second, you convert this. So because these are in kgs, this is in meters. Okay. So and then what else we are missing? So 3 by 4 mass is 100. So this one 20 by 100 whole square. So that's it. You can substitute, guys, now. So 100 cancel, or else 3 by 4 into 100 into 20 into 20 by 100 into 100. Done. So here 100 gets cancelled. So 4 ones are 4 5s are 2 20 ones are 20 5s are 5 cancel. So it's going to be 3. So the work done will be 3 joules. Understood this concept? See, if you don't consider the pure rolling, so we can't find what is omega here. There is no other alternative to do find the omega. Either they did not mention it in the question. If they mention, you can take directly, but they did not mention. So compulsory you should consider it as a pure rolling. Done na? Chalo. So next. So next question. See here. A solid cylinder of mass 3 kg rolling on a horizontal surface with a velocity. So that's a linear velocity, center of mass velocity. It collides with a horizontal spring of force constant 200 Newton per meter. So it is rolling, and here is a spring, right? So it collided with this. So the maximum compression when it collides with this, so it will be compressed, right? Obviously you can apply the conservation of mechanical energy here. So the initial potential energy plus initial kinetic energy is equals to final potential energy plus final kinetic energy. Simple concepts. Okay. So what's the initial potential energy? What is the initial potential energy? If you consider this as the ground, it is on the ground and it is uncompressed initially, right? So initial potential energy is 0. So it is rolling. If it is rolling, what is the initial kinetic energy? Half mvc square is a kinetic is a translational kinetic energy plus half I omega square is a rotational kinetic energy, and then finally it compresses. So half kx square. So plus final kinetic energy 0. It will be, it comes to rest after some time, right? So that I can cancel here half cancel. So then mvc square. In this question also you don't have any choice, so to take other than taking the pure rolling. Why? Because so we don't know what is omega. We don't know what is omega, or you don't know what is the radius of that. If you know the radius, you can find omega by v is omega is equals to v by r, right? So we don't have any other option. That's why I'm taking it as, so vc is equals to r omega. From here omega is equals to vc by r. Okay, so then mvc square I into, so what's the moment of inertia for the solid cylinder? This is a solid cylinder, so which same as of the disk moment of inertia, so which is nothing but mr square by 2. So into omega, so in place of omega I can write vc square by r square, so which is equals to, so the kx square, the only unknown is k, so the only unknown is x, so you can substitute the values, right? So or else first let's simplify the LHS part. Can you do the basic calculations here? So here r square I am cancelling. Here mvc square plus mvc square by 2. So 1 plus 1 by 2 I can write it as 3 by 2 mvc square is equals to kx square. So now substitute the values. So we have got 3 by 2, mass is 3 into vc square, so which is 4 square is 4 into 4 is equals to k is 200 into x square. So from here we can write, so the x square is equals to 3 into 3 into 4 into 4 by 200 into 2 400. So if you do the square of this, so 3 into, so 1 4 will come out by, so here 20. So which is nothing but 2 ones are 2 2s are, so 6 by 10, which is 0.6 meters. 0.6 meters. Option 2 is the correct one, guys. Clear? Understood the concept, everyone? Chalo. So let's take one more question. So a solid spherical ball rolls on a table. The ratio of rotational kinetic energy to the total kinetic energy. So the ratio of rotational kinetic energy to the total kinetic energy. So which one is rolling? So the solid spherical ball. So first this is a solid spherical ball, so having radius r. So solid sphere same as of the disk you can take. Sorry, not disk, sorry. Solid sphere whose moment of inertia will be 2 by 5 mr square. Yes. So then first let's find what is the rotational kinetic energy. So the kinetic energy rotational, which is equals to, I can write this as half I omega square. Half I omega square. So half into what is the moment of inertia of this one? 2 by 5 mr square, right? So 2 by 5 mr square, right? Into omega square, let it be. So this is the total rotational kinetic energy. So here 2 gets cancel. So mr square omega square by 5 you can write. So then, so they are asking total kinetic energy. So the kinetic energy total will be equals to, so the kinetic energy rotational plus translational. The kinetic energy rotational plus the kinetic energy translational. Yes or no? So what's the kinetic energy rotational? Just now we have got, so this one mr square omega square by 5 plus, so what's the translational? Half m, so vc square, half m vc square. So then in place of vc you can write r omega, right? So mr square omega square by 5 plus half m, so vc is r omega whole square. Consider the rolling is pure rolling. Okay, so then only you can take vc is equals to r omega. So here we can write mr square omega square by 5 plus this one mr square omega square by 2. So which is, so here the LCM will be 10. So it goes 2 times. So 2 mr square omega square plus, so here it is 5 times, 5 mr square omega square. So which is nothing but 7 mr square omega square by 10. So this is total, this is rotational. We need rotational to total, right? So let's write, so kinetic energy rotational to the kinetic energy total, the KE total. So what is the kinetic energy rotational we have got? So mr square omega square by 5, mr square omega square by 5 by, so this one we have got 7 mr square omega square by 10, 7 mr square omega square by 10. So mr square omega square cancel, 1 by 5 into 10 by 7. So 2 by 7. So 2 by 7. So which is option 4 is the correct answer. Clear? Everyone understood? Chal. So see this question. Can you guys take this question as a homework? Actually there is one shortcut for this method. So the shortcut is, the shortcut also you can follow. So here you can write rotational translational rotational and then total kinetic energy. So you can write this as 1, this is k square by r square, and then ratio, the ratio. So here what is here 1 plus k square by r square. What is k? K is the radius of gyration. K is the radius of gyration. Radius of gyration. So radius of gyration, how do we solve? For example, see, simply for the ring, if you need the radius of gyration, so for the ring the moment of inertia is I, so which is mr square. So its radius of gyration will be, so just take out the mass and then put the square root for the next one, put the square root, so that it will be r. So if you want for the disk, let's suppose, so for the disk it is going to be mr square by 2, right? So then the radius of gyration will be square root of r square by 2. Take out the mass, so which is r by root 2 you get. So if you want for the sphere, so if you need for the solid sphere, let's suppose, so then 2 by 5 mr square, right? So then we can write it for, so mass you can take it out, so root over 2 by 5 into r you get. Yes or no? So like that you can find the moment, radius of gyration. So for the previous question, if you need, you can do the shortcut. See, so the last question I am solving it here. The last question using this method. So I need the rotational kinetic energy to the total kinetic energy ratio. So right, so which is nothing but k square by r square by 1 plus k square by r square for the previous question, right? So k square by r square by, so here r square is a LCM. So here it is going to be r square plus k square. So here r square cancel. So we get k square by r square plus k square, right? So what is k for the, in the previous question, what is the object that is given? So it's a solid sphere. So for the solid sphere, so just now we derived what is k for the solid sphere. So root over 2 by 5. So k means root over 2 by 5 r whole square by here also. So r square plus so root over 2 by 5 r whole square. So you can cancel. So numerator 2 by 5 r square here, r square plus, so 2 by 5 r square we can write, yes or no? So 2 r square by 5 by, you can take the calculation I am doing here, see here. So this part 2 r square by 5 by, so here 5 is the LCM, so we get 5r square plus 2r square, 7r square, right? So here 5 gets cancelled, r square get cancelled, again 2 by 7 we are getting the same thing, yes or no? So you can do it by the shortcut also. So this is a shortcut method. Understanding guys? Clear? Sure. So this is done. So this question you can take it as a homework. So this question also you can take it as a homework 1 and homework 2. So that's it from my end guys. So this is all about the lecture number 9 of rotational motion. So we'll meet in the next lecture with the pure rolling concept. So till then, keep studying. All the very best. Bye.